Assalamualaikum and Annyeong. My name is Mohamad, Khairul, Hakim, and this is my partner Ahmad, Syukri bin Jamil. Today we will be discussing about anisotropic and isotropic. So before discussing anisotropic and isotropic in details, we need to understand is what is actually crystalline and amorphous. So all solid can be either crystalline or amorphous. So crystals are solid that consist of periodic array of atoms, ions, or molecules with long-range order. So what is actually long-range order? Okay, let us observe this figure carefully. As we can see, there is a regular pattern of arrangement of particles which repeat itself periodically over the entire crystal. The solid is considered crystalline if it has a particle with long-range order which the particle repeats itself periodically over the entire crystal. Usually, crystal is anisotropic, meanwhile, amorphous is isotropic. So, anisotropy is defined as an object or substance having a physical property which has a different value when measured in different direction. Anisotropy can be observed in crystalline solid, which is most easily observed in single crystal because they are arranged in regular lattice. So, today we'll be focusing about anisotropic in single crystal. Anisotropic properties are, for instance, differ with direction. For example, in terms of hardness, cleavability, elasticity, expansion properties, electric or thermal conductivity, electric polarizability, and even magnetization. So, to make it easier to understand anisotropy, the easiest example is karate woodboard. So, in terms of hardness, let me explain by using the example of karate woodboard. Okay, so every woodboard actually has lines in it. So, for example, this is the line. The line is going to this direction. So, for example, I exert a force perpendicular towards the lines, and then I try to exert force like this. Okay, there are two types of direction right here, which is one force exert perpendicularly. One, the other direction is the force is directed on the lines of the board. So, what do you think will require less energy to break the board? The answer is perpendicularly, because the lines and the force is exerted in 90 degrees. That is why it less force compared to the like this. Different orientation causes the different amount of force require different level of hardness. When it hit in different direction, it will produce different hardness type or level. So that's why it is anisotropic. So in terms of electroconductivity, we'll be looking at graphite. So we know that graphite structure is like this. So actually, electroconductivity is very good when the electron is conducted in the horizontally compared to vertically.
Okay, what amorphous is an example of isotropic material. What is isotropic material? Alright, isotropic material is a material that have same structure with identical properties. Right. In this statement, we can say that the material will have the same strength and also the same hardness. Differ from the anisotropic. Isotropic the example of isotropic is glass, plastic, and also wax. Alright. From here, we can see the difference between isotropic and isotropic material. The main difference between anisotropic material with isotropic material is the characteristic of the material itself. Or for the anisotropic material, the example is wood. Right. At the wood, we can see there's a fiber line that is going in one direction. But for isotropic material, the line is not exist and we can see the isotropic material is as clear as a crystal, just like plastic and also glass. Therefore, that's all for the difference isotropic and also anisotropic materials. Thank you.